There's something off about Mercury, and the latest insider information suggests that the James Webb Space Telescope has uncovered evidence of past life on the planet. But that's not all. Mercury might be completely different from what we've believed. It seems that the planet has been hiding secrets right in front of our eyes, and we've only just begun to see them. Exploring Mercury has always been considered particularly difficult and dangerous, and now we finally understand why. Nestled at the heart of our solar system, this planet has been largely overlooked when it comes to major discoveries. However, recent observations, particularly those involving the James Webb Space Telescope, have led scientists to suspect that Mercury has kept a hidden secret, one it has managed to conceal from us for centuries. Mercury is a rocky planet, slightly larger than Pluto but significantly smaller than Earth or Mars. Initially, it was believed to be too hot to support life or any form of vegetation. However, recent findings of water deposits on Mercury are challenging this long-held view, leading experts to reconsider what we know about this planet. It seems that we may need to completely revise our understanding of the solar system. Contrary to what we might expect, Mercury is not the hottest planet in the solar system. Although it is the closest planet to the Sun, with a mere 58 million kilometers separating it from our star, compared to Earth's 150 million kilometers, the hottest planet is actually Venus. Mercury's environment, while extremely hot, is much more moderate compared to Venus. One reason for this is Mercury's small size, which means it lacks a thick atmosphere to trap heat. As a result, the temperature on Mercury fluctuates drastically. During the day, it can soar to 427 degrees Celsius, but at night, it can drop as low as -173 degrees Celsius. This extreme variation is due to the lack of a significant atmosphere to retain heat. Mercury's surface is marked by a diverse landscape, including vast craters that tell the story of the planet's tumultuous history and geological activity. These include massive impact basins like the Caloris Basin, which measures over 1,500 kilometers in diameter. Between these craters are vast plains likely shaped by ancient volcanic activity. Some regions also show signs of contraction, indicating that the planet has cooled over time. One of the most intriguing features on Mercury is its lobate scarps, steep cliffs that can stretch for hundreds of kilometers and rise up to 3 kilometers high. The poles of Mercury contain permanently shadowed craters that are cold enough to harbor water ice. This discovery challenges the long-standing belief that Mercury was too hot to hold ice and opens up new possibilities about the planet's potential to sustain life. The presence of water ice in these regions suggests that there may be areas of the planet that remain temperate, which raises the intriguing question: could life exist in these cold, sheltered spots, possibly in hidden caves or beneath towering cliffs? Mercury's environment, once considered inhospitable, is revealing itself to be a place of extremes. Extreme heat and cold, and perhaps even the potential for life in certain niches. The planet's proximity to the Sun has long made it a challenging target for scientific exploration, but modern technology is beginning to unlock its secrets. Historically, Mercury was a tiny, unremarkable speck in the sky, visible only through telescopes when it passed in front of the Sun. Greek astronomers like Tis were the first to record its position in the sky around 265 BC, but it wasn't until the 17th century that Mercury began to be studied in detail with the advent of more advanced telescopes. In 1631, French astronomer Pierre Gassendi was the first to document a transit of Mercury across the Sun, and in 1771, German astronomer Johann Schroeter studied the planet's rotation. In the mid-19th century, French astronomer Urbain Le Verrier observed anomalies in Mercury's orbit that couldn't be explained by the gravity of other known planets. He proposed the existence of a previously unknown planet between Mercury and the Sun, which he called Vulcan. For decades, astronomers searched for Vulcan, but its existence was never confirmed. In 1915, Albert Einstein's general theory of relativity finally explained the anomalies in Mercury's orbit, showing that the Sun's gravity was warping spacetime, eliminating the need for the hypothetical Vulcan. The first close-up images of Mercury came from NASA's Mariner 10 mission in 1974, which provided detailed photographs and data on the planet's surface and environment. These images revealed the presence of craters and other surface features, and the mission also showed that Mercury has a very thin exosphere composed of helium and hydrogen, rather than a substantial atmosphere. Mariner 10 also detected a weak magnetic field, which was a surprise, as it had been previously believed that Mercury lacked one due to its small size. Despite these early findings, NASA did not send another mission to Mercury for several decades, partly due to the extreme challenges involved in sending spacecraft to such a hot, sun-drenched planet. In addition, Mercury's proximity to the Sun meant that any spacecraft would need to be built to withstand the intense gravitational pull and high temperatures. However, with recent advances in space technology, including the involvement of the James Webb Space Telescope, our understanding of Mercury is undergoing a dramatic shift. What we once thought was an inhospitable, uninteresting planet is turning out to be a world full of surprises, and scientists are now more eager than ever to uncover the secrets it may hold. The future of Mercury exploration looks brighter than ever as we continue to push the boundaries
In a groundbreaking
effort to protect a major space mission from being accidentally consumed by the Sun. NASA embarked on a new journey to explore Mercury's surface in 2008. The mission, known as MESSENGER, Mercury Surface, Space Environment, Geochemistry and Ranging, successfully entered Mercury's orbit in 2011. By 2015, MESSENGER had provided invaluable insights into the planet's geological history, revealing exciting evidence of volcanism, vast plains of lava, and even water ice in the planet's polar craters. These findings sparked further curiosity among scientists, as they suggested that Mercury might be far more dynamic than previously thought. Evidence of the planet's violent geological past indicated that Mercury was not a dormant world, but one with a potentially active interior. Some researchers even propose that Mercury could have once been located farther from the Sun, perhaps in the habitable zone of the solar system, and was later pushed inward by Jupiter's gravity. This theory raises the intriguing possibility that Mercury might have once supported life, akin to Earth or Mars. As scientists continue to study Mercury's peculiarities, the James Webb Space Telescope, JWST, is poised to bring new understanding. With its advanced capabilities, JWST is designed to examine even the faintest objects in space, such as small exoplanets passing in front of their stars. Mercury, a tiny planet near the immense Sun, presents a similar observational challenge, but JWST's precision can detect minute changes in light, allowing scientists to separate the planet's reflected light from the Sun's overwhelming brightness. If successful, this could provide unprecedented data about Mercury's surface composition. JWST's observations may determine whether Mercury is an inert, cold world or whether there are still unexplored activities on its surface. If evidence of water is found, it would revolutionize our understanding of Mercury, revealing it to be a far more complex and enigmatic planet than we previously realized. Despite being overshadowed by its larger neighbors, Mercury continues to surprise scientists. One of its enduring mysteries lies in its geological activity. The planet's surface shows evidence of past volcanic eruptions and tectonic movements, with numerous impact craters suggesting a violent history. The Caloris Basin, a massive impact site over 1,500 kilometers in diameter, is a testament to these ancient disruptions. Around these craters, volcanic plains formed by lava flows offer further insight into Mercury's dynamic past. Mercury's proximity to the Sun also causes its atmosphere, or exosphere, to be extremely thin, primarily composed of helium and hydrogen, with trace amounts of other gases. Unlike Earth or Venus, Mercury lacks a substantial atmosphere to regulate its temperature. As a result, the planet experiences extreme temperature fluctuations, soaring to 427 degrees Celsius (800 degrees Fahrenheit) during the day and plummeting to -73 degrees Celsius (280 degrees Fahrenheit) at night. These harsh conditions challenge the possibility of life, yet recent discoveries of water ice in permanently shadowed craters at the poles have intrigued researchers. This water ice, thought to have accumulated in the frigid regions, could be a vital resource for future exploration. Mercury's orbit around the Sun is uniquely fast, completing a revolution in just 88 Earth days at an average speed of 47 kilometers per second. Combined with its slow rotation, this creates a distinct pattern of day-night cycles and exposure to sunlight. Studying Mercury has been difficult for space agencies due to its proximity to the Sun, but missions like Mariner 10 in the 1970s and Messenger have provided close-up images and valuable data, improving our understanding of its surface, magnetic field, and exosphere. Looking ahead, the James Webb Space Telescope, JWST, promises to advance our knowledge of Mercury. With its cutting-edge imaging technology, JWST will analyze the planet's surface composition in remarkable detail. By observing Mercury as it passes in front of the Sun, JWST will gather data on the planet's atmosphere and surface features, potentially revealing new insights into its geological history and the possibility of water or other volatile substances. These discoveries could reshape our understanding of Mercury's development and evolution. By comparing Mercury with other rocky planets in our solar system and beyond, scientists aim to uncover universal principles governing planetary formation and the potential for life. Despite its harsh conditions and small size, Mercury remains a fascinating object of study, continually surprising researchers with its complex geology, orbital behavior, and potential for harboring water ice. Future missions and advancements in space observation technology will continue to unlock more of Mercury's secrets, offering new perspectives on the development of terrestrial planets and the conditions necessary for life.